This is a video of principal communication, and we are going to focus on pulse code modulation, PCM. Do you know what is pulse code modulation? A method used to represent an analog signal in terms of digital word. It involves sampling an analog signal at regular intervals and coding the measured amplitude into a series of binary values, which are transmitted by modulation of a pulse. Next, we move to processes of PCM. There are three processes: sampling, quantization, and coding. Sampling is the process of measuring the amplitude of an analog signal at regular intervals. The rate at which the samples are taken is known as the sampling rate or sampling frequency. It is usually measured in hertz. It must be sampled at least at Nyquist rate to avoid aliasing. Aliasing is overlapping of frequency component. Aliasing need to be avoided to prevent any data lost. As you can see, the frequency of the modulated signal is smaller than Nyquist rate cause the frequency of modulating signal and sampled signal is overlap. For quantization process, it is the process of assigning a discrete value, represented by a binary code, to each sample obtained during the sampling process. Quantization level depends on the number of binary bits, n, used to represent each sample. L equals 2 power of n, for example. For n equals 5, quantization level, L equals 2 power of 5 equal to 35 level. What is bit depth? It is the number of bits of information in each sample. For example, 1001, 1100, so each number represent 1 bit. So this example have 8 bits. Lastly, is coding. The quantized values are then encoded into binary code. Each quantized value is represented by a binary number and quantized sample into digital signal. Increasing the step size between adjacent quantization levels will reduces the quantization noise. Some of pulse code modulation are used in long-distance communication. IT also has higher noise immunity when compared to other methods. Other than that, IT can be multiplexed onto a single communication channel. Lastly, it is cost reduction via faster transaction speed. Moving on to multiplexing. Multiplexing is a way of combining numerous analog or digital signals into one signal via a common media in telecommunications and computer networking. It is process of transmitting two or more signals simultaneously. In telecommunications, for example, a single cable can carry many phone calls. Frequency division multiplexing, FDM, involves the simultaneous transmission of multiple signals over a shared communication medium by allocating each signal to a unique frequency band. In the context of FDM, the terms MUX, multiplexer, and demux, demultiplexer, are crucial components facilitating the combination and separation of signals, respectively. There are few advantages of multiplexing, which are: multiplexing can increases the overall bandwidth efficiency. IT also make number of signals or users increases. Besides, it's easier to add them to the multiplexed channel. Lastly, IT designed to minimize interference between different signals sharing the same channel. There are few applications for multiplexing we can know. Firstly, is television broadcasting. TV channels can be transmitted over the same frequency band using frequency division multiplexing. Secondly, satellite transponder. Multiplexing is crucial in satellite communication to combine multiple signals into a single channel for transmission. Thirdly, IT can secure the communication, employing encryption and spreading techniques, making it difficult for unauthorized users to intercept the communication.
Professional engineering issues in pulse modulation and multiplexing. Firstly, in terms of health and safety, engineers must minimize electromagnetic radiation risks and ensure non-ionizing radiation exposure adheres to safety standards. Safety considerations involve designing reliable systems and preventing interference in multiplexing. Moving on to legal and regulatory compliance, spectrum allocation adherence is mandatory, and privacy laws must be observed to protect user data. Now, let's discuss cultural sensitivity in engineering. This involves inclusive design for diverse populations and considering the cultural impact of technology advancements. Lastly, the responsibilities of professional engineers include continuous education to stay updated with evolving technologies and ethical considerations in design and implementation. In conclusion, navigating these professional engineering issues ensures the responsible and effective deployment of pulse modulation and multiplexing technologies in telecommunications.
5G is the fifth generation of mobile networks, following on from previous generations. It's set to offer much faster connection speeds than previous networks. Also, being more reliable with lower response times and greater capacity. 5G achieved the expected data speeds of 10 Gbps. This will be 100 times faster than standard 4G and also 30 times faster. There are also reduced latency, meaning that faster response times as well as fast download speeds. For example, that it would take between 4 and 40 seconds to download a full HD film on 5G, as compared to over 7 minutes on 4G and over a day with 3G. That's all for pulse code modulation and multiplexing. Thank you for watching. Bye.